Hey guys, today we are gonna check out doing some programming on top of the RPC JSON layer in cryptocurrency. So all cryptocurrency has a RPC JSON layer, basically a way to program on top of the currency so that you can send money, you can um, create new addresses, a whole bunch of things you can do. I'm going to use Burst because there's an online version of it with a robust API, very easy to program, and it will help those in learning how to, do development in cryptocurrency. Take this a step further. So let's start with Burst. All right, so we've got a number of development environments that we can choose from. We could do .NET, we could do Python. I'm going to use Microsoft Excel just because VBA is just quick and easy, get off the ground running with quick results and not much code, and you could be programming cryptocurrency in it. So we're going to launch Excel and start with a blank workbook. We're going to go into our IDE. You can get into it either by going through the developer tab or hitting Alt F11 on your keyboard, and you can do that from any Microsoft Office application. Alt F11 will take you into the IDE, and we could do this in Word or PowerPoint, Access. It doesn't matter. I just like Excel because you've got the visuals, so we can pull the results back from our web calls right into the Excel front end. So go into the Developer tab, Visual Basic. What we're going to do here is now, just to give you a little preview, you've got your project. Like your objects up here in the upper left. So we've got the VBA project object, which is the top level. Then we've got the workbook, and then the sheets in the book. We're going to add a module, and we're going to name this module, and we'll just call it ModGet. All right, because we're going to be talking to the web, we're going to need to use the XML HTTP library. Now, even if we had and I do have other cryptocurrencies, downloaded locally, you would still, even though it's running locally and you want to make a call to your local computer, you're still going to use that XML HTTP library. So it's the same call regardless of whether you're running it locally or you're making a request from the web. So we could do early or late binding with this. We'll do some early binding. Oops, made a mistake. References. And we're going to look for Microsoft XML HTTP library. There it is, XML version 6.0. All right, so number of things that we can do with Burst. Burst is a fork of Nextcoin, and very robust, in my opinion, probably the most robust cryptocurrency out there. Most cryptocurrencies like Bitcoin and Dash, you have the ability to send and receive coins, and that's it. As you can see with Burst in this example, there's so many other things you can do. You've got decentralized encrypted messaging, aliases, which is basically a decentralized DNS system. You've got stores, so decentralized online store. I think, if you're going to use a decentralized online store, I'd probably use OpenBazaar. Well, that's your store in the marketplace, same thing. Crowdfunding, asset exchange. Asset exchange is beautiful because you can create an asset and then reward that asset for a certain product. So an example that I had built previously was a raffle system, a provably fair raffle system that after the raffle was awarded or won, it would reward the holders of the assets. So you could actually buy stock in an online decentralized cryptocurrency or an asset of it. All right, so what we're going to do is we're going to automate just sending people messages. So we'll send people a message and some funds. We'll send them like one burst, which is like not even a cent. So one of the first things we want to do is to find out how we can investigate this API. So Next, and by extension Burst, has built in a very robust API, which you can access by going to the address you see in the browser there and replacing the index, which is your login, with test. And now we'll get a list of the API calls that we can make. So as you can see, we've got a ton of API calls. Now, if you look at the documentation for Bitcoin and Dash, Pivx, and all the other great cryptocurrencies out there, typically there's only a few calls that you can make. I mean, you can do a lot of calls, but essentially what you're doing is sending, receiving, creating new addresses, and that's about it. With Next and Burst and a couple of the other forks of Next, there's so much more you can do. So we're going to focus on the messaging, but before we get into the messaging, what we have to do is we have to figure out who are we going to send these messages to? And we don't want to hard code that stuff. We just want to automate it. So, one of the first things we'll do is we want to get block information, like the most recent block information. We want to interrogate it and see if there's any information in that block that will give us addresses that we can then email. So within the blocks section here, we've got a number of calls we can make. Get block is the one that we want because this will give us, without any parameters, the most recent block on the Burst blockchain. So as you can see, we've got the block, the height, tons of information. The thing that we're most concerned with is the height, because this is the sequential numbers of the blocks that we're going to interrogate, and we're just going to work backwards until we find transactions that we can then investigate, find an address, and then send people some coin. So as you can see, we can check out the get call that we're going to have to make just by clicking that open get URI, open get URL, and it will extend it to us for us with all of the details that we need. So that's the call that we're going to make. So we'll just copy that into our IDE. So within Excel, we're just going to create a sub here. So we'll just say public sub, and we'll call this block, or we'll call it get block. And we'll just put a remark in here with the call that we have to make, just so we have it ready. So now, since we've early bound the XML HTTP library, we can dimension it. So we'll just say XML as a new XML HTTP. And then very easy to work with, and this is across all programming languages, super easy in Python and in .NET and Java. Within a few lines of code, you can get running with web services. So, we're just going to basically open up a channel to, so our B string method here is string is either predominantly it's get or post. I think there's a few other choices that you can go to, but and I'm surprised it's not enumerated, but we'll just put it in as a string as a get, and then the URL that we need, and that's what we just copied, and we got to put that in as a string. Now we can put all this information right in the get call without a header because there's no sensitive information. Now later when we do a post, we'll put a header so that it does the call properly without potentially exposing our credentials. So you have to now send this call, and that's it. We will now have essentially the data that we're looking for. So we'll just put that out into the immediate window. So we'll look at the response text from there. And when we execute this, I'm hitting F5 on the keyboard, or I can also, go to run up here, CF5. And we should get that essentially the same thing that we got out on the web page, and that's what we got. So the thing that we're looking to get here is the height. Because the height, again, it's the sequential string of the blocks that we're looking to interrogate. So let's create a variable that holds the height for us, and we'll call it L height, since it's going to be a long. Oops. There we go. It's got to be dim, not sim. So now there's a number of ways to get this information from that string that's been generated, that OXML response text property. The right way to do it would be to make a reference to the JavaScript library and then extrapolate it the correct way. But just for expediency's sake, we're gonna use some string manipulation, and it's quick and easy. But again, just keep in mind when you're watching this, right? If you wanted to build this in a robust fashion, you'd probably use like the embedded JavaScript library that I'm sorry, not the JavaScript. It's the JSON library, the scripting library, right? And then we can do JSON calls from there. So, but again, we're just doing this for speed, so we'll just use string manipulation. So real simple here, we're just going to say, hey, we want the mid of the response text, so what we're getting back, and we want to start where we find the word height. So where we find the word height, so we're going to say in string XML response text, and we're going to start. Oops, did that wrong. Start at 1. Get my languages mixed up sometimes. And we're looking for height. And so we want to then jump over. As you can see, if it finds height, which it will, it'll find the first instance. We want to jump 1, 2, 3, 4, 5, 6, 7 characters. So our starting point will be the 7th character in. And again, this is a sloppy way of doing it. Normally, I'd have a constant for the thing that I'm looking for, because we know we're going to use this later. Code could be a lot cleaner, but we're going for speed here. Okay, so the length is going to be, we just basically look for the first comma. After this, subtract out the prior results, and then we're good. So if we say, hey, in string, and we're going to start at this number, in OXML response text, and we're going to look for the comma after that. Now that number, if we subtract out oh yeah, did I? That's where it's the first one. This is the start. This is the thing we're looking for. Then the comma. And then minus that baby. See if I got it right. We'll get a type error if I'm wrong. Yeah, type mismatch. So let's see where I messed up. Let's see what this looks like without casting it as a long. We'll just look at it. Oh, I really got it wrong. All right, so I miscounted here. So we want to start at the 8th character. And then start at the 8th character here. 8th character here. Okay, let me see how that looks. I get the feeling that's wrong too. Why am I? So start at height plus 8. Right, this length. I wonder why this length is so long. Oops. I'm going to take a step back here. Do this the right way. So we'll do a long start. It's long. And the comma is long. All right. I embedded too many things, lost track of where I was at, so we'll just do this the proper way. So we're going to replace this first component with lstart. So we'll say lstart equals this. So everywhere where we see this, that will be our starting point. So there's our start. And we could do that for the 2 other times that it occurs. Let's see what we get. So we'll still get the, oh, we didn't get a type mismatch. Why did it suddenly work? All right. So it's starting at 42. See if it got the right L height. Oh, it did. Okay, I finally got it. Not sure what I did differently there, but yeah, sometimes, you know, you go to do things quickly and it actually takes you longer. So, all right, we're taking out this comma as we don't need this since it's working just fine now. All right, so now we have the height. So with the height, we can now figure out what transactions are either in the current or previous blocks, because that's ultimately what we want to look at. So let's go back and look at you know, the current block again. It probably changed because it's been a few minutes. All right, same block. And we see this one has a transaction. So because this one has a transaction, we don't have to worry about traversing backwards up the blockchain. We can just stick on this current block, investigate the current transactions, and then find an address that we want to send a message to. So this transaction thing we'll find in the same fashion that we did before. So we'll go back to our code, and we'll just create another routine here. We'll make this a function. So we'll say public, make it a private function since we're not going to call it outside of this module. So private function transaction. And then we want to pass in the height of the block. So it's a long. String works fine here too because it just does. Not sure what we're passing back yet, so I'll just put a catch-all variant in there. But it'll be a string or a long most likely. And same thing, we want to find the transactions. So we got to go back to our API list, look up transactions. Here's one. And let's see if we have something. Yeah, there we go. Get transaction. So if we put a transaction in, we in a properly formed post, we should get a list of all the transactions for that block. So let's just go grab that current block. get a transaction, get that particular transaction, and then see what was encapsulated in there. There we go. All right, so one transaction that we're looking at within that block. There we go, gives us an address. So this is perfect. So now we can extrapolate out this address from the transaction. But the first thing we have to do is make this get transaction call. So we're going to do the same thing, open a get URL, even though it's, yeah, this is a get. And so we just have to form this call. Now I should have made just one master XML call just to handle all of these different types of get and post requests. That would be the proper way to do it. But again, we're doing this for speed. So, we're gonna just copy that code just so we can get through this without just quickly, basically. All right, so we're going to copy in this request. And instead of this hard-coded transaction, we want to pass in the one that we are getting from our parameter in this function, which is the height. And because it's a get call, we don't have to worry about embedding all this data up in the top. We don't need any headers. And we should get the same thing. We should get our results in the debug window. So we'll just take a look at this really quick. Response text. And then we'll go up here and we'll make the call. So we'll say go up here, we'll say transaction L height, the same variable name. And when we run this, we should see the JSON response. Yeah, we don't need this variable. We don't need start either. We run this. Unknown transaction. All right, so when this happens, I typically just step through the code and see what's up. So we got 659781. That's our block height. Oh, totally did that wrong. We need to first extrapolate out the transactions within that existing block. So do the same thing up here. We'll just reuse the start variable. So within that block, we're going to say give us the transactions. And it's going to be essentially the length of this block, but plus the quote, colon, quote. So basically the length of this plus 4. So 1, 2, 3, 4, 5, 6. Looks like 12 plus 4, so 16. Okay. And then we'll create a long variable for the transaction. So same response text, the new start, and then same as the ending over here. So I'm just going to copy this over. And hopefully that'll give us the transaction. So we'll stop it here. Hopefully it works. Nope, type mismatch again. All right, so let's see where I went wrong. So it's starting at 899. So we'll just do a quick mid on 899 on OXML response text. So 899, and we'll just get the first 10 characters. Looks like we might have the right starting point. Yeah, 220. 220. Well, one way to remedy this is just make this a variant or a string. We'll make it a variant temporarily and see what it looks like. All right, so we got 2 extra characters there, so I just have to slice off 2 at the end, and that should give us the transaction. And we'll leave that as a variant. That's fine. So let's see if it gives us the transaction that we're looking for. There it is, 220, starting with 220 and ending with 74. Yep. All right, perfect. So now that we have the transaction, we can interrogate that transaction, and instead of height, I should be saying L transaction. We're not passing in the height, we're passing in the transaction number. There we go. All right, so now we should get details on the transaction when we run this again. So I'm hitting F5 from the parent sub here. All right, because I passing different types, we'd have to do a by ref, but we'll do it the right way. We'll just pass in the correct type. Hit F5, overflow. All right, so the block may have changed, and there might be no transactions in this block, which will now lead us to, oh no, it's good. All right, let's go back to the variant, see what happens. Rather, it's not a ref. There we go. Okay. So now what we have is the transaction that we are requesting. And as you can see, we've got some recipients that we can look at in the recipient RS field. And again, we're going to just extrapolate it out with string manipulation as opposed to the scripting library, and just try to get the results quick and you know send a message to that address. All right, so we're going to do this all right within the same sub. So we will say we want to get the recipient RS, so we're going to just say give us the same thing. I'm going to call this variant start, just so I avoid any type errors like we did at the top. So vstart equals in string, start at 1, got our XML response body or text, And then we're looking for recipient RS. I think that's how it's spelled in there. So that'll give us the starting point. We could say to recipient as variant also. vrec equals to a mid of the same body. And we're going to start at vstart plus the length of recipient RS plus a couple of extra characters. So let's see. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it looks like we'll start at the 15th edition. And then these burst addresses conform to a standard length. So we could do a standard length, or we could do it the right way and look out for the next comma and just absolutely grab that address that way. But we'll just go with the hard-coded amounts. We got 5, 6, and 4 is 10, 15, 16, 20, 21, and 5 is 26. So it looks like it's 26 characters long. And that should give us the recipient address that we're going to end up sending a message to. And we'll just verify this by printing that out to the debug window, see how it executes. So go back to our top level function, execute, see if we get any errors. I don't see any errors, but let's. I also do not see the recipient. It looks like I maybe started too far. All right, so unknown transaction. Okay, so let's see what transaction we're pushing in. Okay, so we got a new block, of course, and a new transaction. And for some reason, it doesn't know this transaction. So, which is kind of weird because we just pulled the transaction. So let's see what the most recent transaction is. So we can just refresh this current block and see what's up. And we got transactions. Oh, okay. Right, because this is a collection of addresses of transactions. We now have a different format than simply just looking for the prior or the next comma. We need to look for the closing quote. So slightly different approach when there's more than one transaction. And again, like I had said, we probably would want to use the, let me stop this.